All right, good morning, everyone. It's 10 a.m. Welcome to another round of the long coffee break. I've got Richard Zhang with Swegon here today, and we're going to talk about some VAV chilled beams. With that, I'll let Richard take it over.
Thank you, Jordan. Thank you, Michael. I'm Richard Zhang. I'm a regional sales manager for Swegon. I already serve the Denver area through my previous company, Viber Acoustic, and then now Swegon for more than 15 years. I'm so glad to see so many familiar faces in the lobby and over in this show. So just wanted to go quickly regarding to the chill beam. Chill beam is a very simple terminal unit. You just imagine there's a coil behind the diffuser. But when you design this, make sure you bear two concepts in mind when you design them properly. The capacity equipment with the induction, and at the same time, it's a diffusion equipment. So you want to distribute the air properly. The reason why we want to promote Chilbin in the Denver area. So first of all, I want to clarify the name. Chilbin, to be honest, is really a terrible name. Chilbin not only good for the cooling, but also good for the heating. That's reality. On the other hand, we believe the Denver weather condition is great for the Chilbin application because from what I know, the latent load is generally speaking lower than other territory. For example, much lower than Houston I just visited last week. On the other hand, I believe the electrification is on the go in your area. Everybody pushing very hard in Denver for the electrification building. And I'm very happy to share Swegon has a full package to help you to achieve that goal. So here is a chill we'll definitely will spend a lot of time to talk about today. We also have a Swegon semi-custom built air handler. And now we officially launched a chiller heat pump with 454B new refrigerant. So you will not worry that you are going to be phased out in January next year. So going back to the chill bin again, because there's no moving parts, so the maintenance is pretty much the minimum. On the other hand, that can be bad news for a noise control guy. There's no noise, so there's no noise, no draft, less stratification, so much comfortable for the occupant. And on the other hand, I'm going to spend another slide regarding to the efficiency, so I'm not going to talk about anything about that. But the other reason is there's no drain because tubing is designed as a dry equipment. The DOI system will taking care of all the latent load, and tubing will only take in the sensible load. So as a result, the core is always dry. There's no risk of a mold and and a mildew. So coming back to the other benefit of the tubing over other equipment, they're significantly reduced the refrigerant use. It may not be a big deal when we are using R410, which is A1, not toxic, not flammable, so that's not a big deal. But you have to bear in mind, when you switch over to A2L, it's a flammable, so any reduce of the refrigerant can be a benefit, especially against the VRF system. On the other hand, they have a much lower power consumption. I have to be honest with you guys, the quote I put over here is not from Swegon. It's actually from the one of the local design build contractor in Denver. So Chillbeam basically use 20% less power than VRF and 33% less power than traditional all air system. Let me see if I can get my Yeah, and I think everybody will pay attention to, hey, that's a great system. How much money going to cost? Again, this is a quote from the design build contractor. You know, they not only looking for the mechanical system for the first cost alone, but they look into the overall cost. So Chillbeam can generate a cost saving of 30% or more, comparable to all air and the VRS system, making them a financially appealing choice for many buildings. Again, going back to the maintenance, compared with a traditional fan coil or a VRF system, Chillbeam has no fan, no filter, and no drain. So as a result, the only maintenance that you really need to put on is to vacuum the dry coil probably once per 2 years, and inspect the valve and clean the visual sparks. However, there's another benefit. That's why it's kind of appreciated and applied by many of the owner of the buildings. The chill beam can last 30 plus years. Going back to the reason, no fan, no filter, no drainage. However, as a comparison, the fan coil or VRF unit can only last 8 to 12 years. So again, before we jump on to the new generation of chill beam system via VAV chill beam, I just want to emphasize again, chill beam is not only the capacity equipment with the induction, but also the air distribution equipment. We are going to explain to you why the VV box in front of the chill beam, constant airflow chill beam will not work. So with the trend, there's a lot of push for the demand control system. So chill beam can be a great candidate for saving the energy. And then people, including many leading consulting firms, began to think, how can we marry those two best energy saving technology together to save more energy? So one of the try is to put a VV box in front of a constant airflow chill beam. You know what happened? The result is that they're incompatible. They lost the induction and consequently they are losing the cooling and heating capacity. So that's the capacity side of the story. On the other hand, they lost the velocity and then they lost the coulombic effect. And then the chill beam will basically pretty much dump the air into the space. So I'm going to show you two interesting video clip we have in our testing lab. The first one showing the two-way chill beam designed properly. You can see here the air coming out, stick onto the ceiling because the coulombic effect, and then you make sure you flush the wall. So you're taking care of all those sensible load. At the same time, did you see the air coming back to the chill beam? That is because of induction. So that is a properly designed chill beam system, mixing the air very properly and distribute the proper temperature in the room. However, on the hand, if you have a VV chill beam just in front of the constant airflow beam, when you barely close the damper a little bit, this is what happens because they lost the velocity. The first thing you see is they dump the air to the person right below the chill beam. On the other hand, make sure you watch it to the end of this video clip. The air never ever go back to the chill beam. In other words, they lost capacity. However, now, just for information, Swegon provided solutions through long buildings. We are providing variable geometry nozzles. We can maintain the critical pressure through all the airflows. You're going to maintain the induction. We also provide the maximum turn down. I can't even tell it's a 10 to 1 because we can basically completely shut down the valve, or we can give you the 100% of the airflow you specify. There are two versions. The first one is controlled by actuator to do the proper demand control, CO2, humidity, whatever you want to achieve. So the DDS system. On the other hand, there's a version you can see over here. There is a manual adjust knob. Please never, exclude that option out because that can be a great candidate for you to do the repurpose of building. On the other hand, because the increased capacity of the chill beam, we help simplify the selection of the chill beam design. Instead of having 2x2, 4, 6, 8, 10, and multiple unlimited, nozzle design for every single constant airflow chill beam. Now we limited the size to 3 only. That can be a very good news for the designer in the consulting firm. Just imagine if you design a constant flow chill beam system, a decent project will probably make 500 selections. That probably will reasonably take you like 2 to 3 weeks. But for the VV version of chill beam, you know how many lines? You just need to make 3 selections, 2x2 for 0 to 100 CFM, 2x4 up to 200, and 6 inches for the 300 CFM. The another innovation we make over here is to make the insulation more flexible. So in the traditional way, when you use as a mechanical engineer, you have to review the submittal from the tube manufacturer. You had to confirm and approve that it's right-handed or left-handed. But now with innovation from Swegon, you can have a connection, air connection from all four sides. So even you decide it's right-sided, and then the product divide onto the drop side to be left-sided, you can easily convert from the right connection probably within 5 minutes. Again, another good news is we already extended the VAV version of Chillbin through all the product lines. Not only those on the left side 4-way through, but we also extend the service and the VAV version to Paragon. That can be a good one for the patient room or the hotel room. The one in the middle is Adriatic for the exposed ceiling. If you still want to use the 2-way through, we can give you the VAV version of Pacific or the Primo. The other news I want to share with everybody to the engineering community in Denver area is we are ready to release the selection program to everybody. It's a web-based. The difference is it's not only selection program, so you can export the schedule in Excel format and populate into the drawing. It's also a simulation program. So you can see even before you design the project, if there's a confliction of the airstream or if they're able to flush the wall when you design the system with a 3D demonstration. Here we are going to go through some of the examples. Depending on time, we may not go through all of them. So the first one is Adriatic. You can see here there's exposed ceiling. It's actually the trend in the industry we observe. The architects actually pushing very hard for decarbonization. So they're basically pushing to limit the dropping ceilings. So to let you guys know, we have a solution to meet that requirement. And this one is the patient room. So you can see on the right corner over here in the bulkhead, we have a Paragon Swegon chill bin to provide the comfortable room temperature into the patient room. On the other hand, this can be the same application, but for the hotel room. Just for you guys' information, we are actually supplying the same design to the CTM Hotel project in Denver. We are the global partner for the CTM Hotel, so we have multiple locations: Los Angeles, San Francisco, Houston, Austin, and Miami. We're taking care of that latent load very well with the chill bin design. And this one, chill bin is very popular, like I pointed out, for the owner of the building. Obviously, the university is one of them. We supply the Arizona State University ESU with the active demand control chill bin to meet their lab load requirement. For the traditional one, for the classroom or the office building, we can put the chill bin on the parameter called the Primo. They basically blow up, similar to the traditional induction system from a carrier. This is another example. However, that can be designed for the end floor application as well. If you have a data center, maybe this one can be considered. And here's the one for the Pacific. The unique part is they do not have a drop-in ceiling, so we have a coanda effect help to distribute the air. At the same time, to meet the architect requirement, we have continuous looking of the chill bin design. This is the last one, Parasol with AstraZeneca. Because the 4-way through, we help eliminate 1/3 of a 2-way through chill bin. Yeah, that's it. I want to share with everybody. Thank you. Give back to Michael.
Thank you, Richard. If anyone has any questions or wants to learn more about Swegon's VAV chill beams, please don't hesitate to reach out to your Long sales representative. Please join us next week when we have Lindsay Flatter going over the Pro-R duct. Learn why this pre-insulated exterior ductwork should be your first choice. And with that, we'll end this presentation, and I appreciate everybody joining this morning. Have a great rest of your week. Thanks.